We are live for day 17 of Advent Code in 6 minutes, just in time. I was out too late playing poker today, but I did make some money. Okay, just checking on things, making sure this last minute thing isn't backfiring on me. Okay, everything looks good. Everything looks good. So in 5 minutes, well, let's at least get this set up. I was thinking if I'd gotten here earlier, I would do. Oh, yes, I'm hoping for the difficulty increase. It's about time, isn't it? We haven't had that, like, big problem that everyone complains about yet. We haven't really had a Dijkstra problem either. So, I don't know, maybe that's tonight. But LHF to you. I'm gonna check on the leaderboards. Where am I? Fifth, still holding fifth, still holding second here. But this gap is closing. It's been closing the last couple of days, and I think I can make it. We have, what, 8 more days? Thank you, thank you. Oh, you know what? I'm missing one thing. Let's get those messages on screen. Just do a little test here. Oh no. Oh, I should have tested this beforehand. Okay, I don't think we have messages on screen tonight. Let me try a couple of reloads here and here. Okay. There we go. We're good. We are good. Stream is ready to go. 3 minutes left. I was doing some day 16 cleanup. What I really need to do, though, is some performance improvements. Right? This takes too long. In fact, actually, you know what? I think I want to close this file. Well, no. If I just uncomment or comment out this bit that takes too long to run, then we can work on the refactor here. Okay, this main logic looks good to me. I mean, honestly, the code is clean enough. At this point, I just have to think about performance optimization. And I was thinking some sort of memoization, right? Like I did this to prevent infinite loops. I still need to prevent infinite loops, but if I do some sort of memoization, I think a lot of these mirrors will have shared like paths forward. Or I can do like a pre-compute on mirrors, basically how long of a path is there north, south, east, and west. I think that's probably the best bet. And what mirror does it hit, if any? So I'll write a note about that. But again, we are watching this clock. So, pre-compute paths from each mirror optionally to the next mirror hit. And would I also ignore mirrors that don't affect the path. Maybe it would take it out of this, which I do really like this block a lot. And honestly, it goes both ways. I could do like an adjacency graph of mirrors and then the amount between them. I don't know. I don't know. I mean, let's take a look. Yeah, I mean, there are a lot of places there, but we're not going to do that because we have 20 seconds left. Okay. Oh, good morning, Blue. Yes, I see the volcano animation. Our calendar is getting interesting. Although, you know what? Honestly, I haven't been following the story as well as I should have. Okay, here's day 17. Ooh, lots of numbers. It looks like they're fairly low numbers, like nothing higher than 5. Um, okay. Direction, what is the least heat loss they can incur? Okay, so paths incur heat loss. This is a Dijkstra problem. Okay, we close this. We have day 17. This is just the grid. Val area is area of that grid. Okay, so from the lava pool to the machine parts factory, to minimize heat loss while choosing a route that doesn't require the crucible to go in a straight line for too long. Oh, okay, we can't go in a straight line for too long. So slightly more interesting Dijkstra here. Ambient temperature, hundreds of other parameters to calculate. Each loss could be affected for any crucible entering any particular city block. Okay, where do we start? Okay, the starting point is a top left city block. The destination is the bottom right city block. Okay, we're gonna do a priority queue here. You know what? I don't want to code this on the spot. I'm gonna grep. I'm gonna grep worksheet. And we're gonna grep for priority queue. Okay, 2022, day 24. Yeah. In fact, that day we did not just extra, we did A star. Right? We had this kind of thing. I'm gonna copy paste. Okay, we have a start point, we have an end point that we're trying to reach, and there's a time. I don't think we want a time. This here is our ordering for the priority. priority. And what should our state be? We can move at most 3 blocks in a single direction before it must turn 90 degrees left or right. Can't reverse direction. Sure, we're not going to do that. Okay, so a state then is not just a point, but a point and a number. Um, we'll just do a state, pause, point, and not time, not time. What we want is straight count. And we are only going to use the distance to end. So s.pause.dist to end. I wonder if I'm shooting myself in the foot there, not considering anything to do. This is probably good. This is probably good. Start and a 0. And then we have the set that we're visiting. Visited is this state right here. Okay, next states, we can go move at most 3 blocks. So 1, 2, 3. Next states. Okay, let's just define next states in here. Def next states. And this will be based on straight. If straight is less than 2 or less than 3, right? If it's less than 3, then still keep going straight. Then that's almost right. So edge. You know what? The direction matters here too. So let's say dir. That's the direction we've been moving. When we start out, there's actually no direction. Or it's like 0 straight in any direction, right? So this could say north for all we care. Well, it should say forward because we could also turn. Now if we go in the same direction, so we're going to do this. List of paws that move in that direction and paws that move turn right or turn left and turn right, whatever. Order doesn't matter too much. Okay. And well, there's also some more state to this. So let's just do that. And some of this here depends on the direction. So if we're moving in that direction, we're going to do a 1. If we're moving in a new direction, it's also going to go to 1, right? So yeah, it's just going to be straight plus 1. Um, and then the new direction is going to be like dir dot turn right, turn left, and turn right. This can be made a little bit cleaner, but this will work. And then we're going to filter for area.contains. And you know, we straight up return that. And then otherwise we do this. And we take out this first state here. We can turn left or turn right as long as they're still contained. And heat loss. Okay, so there is a heat loss, and we want to minimize that. So that's part of our state. Heat. We should do like a next dir variable and map it into here. Because then we get like this next position. Okay, what I'm going to do right now We can refactor later, but right now we can multi-line edit. So after this straight, we're gonna do the new heat. So heat plus grid value that to int. Wait. This is a character. As digit. Yeah, we're gonna do as digit of paths that move in that direction. Turn left and turn right. That's way more code than it needs to be. I could generalize. And what's the issue here? This is a... Oh, yes. So we have the state, error that contains s dot pause. Okay, great. And now we just copy paste this again and remove the first line. And then visiting that heat loss. What is the least heat loss that can occur? And then val ans1 equals search from, we have a start state. Oh, hold on. We define it here. Yeah, let's say we're facing third.east. We have 0. And do we start on 2? Or I think it's just when you enter. Okay, so we start at 0 on the heat loss 2. So that's our start. This 2. I think it's just dist. There we go. And then we return visiting that heat. Now we search point at origin, and then area.bot right. Index out of bounds. -1 is out of bounds of 0 to 140. Okay. I thought we were checking that. Pause that move direction. Area should contain the position, right? So I mean that's fine. Oh, right. This here is computed in advance. Okay. We write this properly. So val positions, or directions. We're gonna map them directions. Val directions equals list dir.turn left turn right, and then directions.map dir. We're gonna do a filter first. So let's just do filter here. Dot filter. Pause that move dir. Area.contains. Area.contains. Okay, great. And then now we take the directions and we map. We'll just call this new dir. And we have state, pause that move, new dir straight, heat plus grid at pause that move, new dir. Okay. We'll just call it new pause for good measure. And take this out. And then grid of new pause dot as digit. Okay, there's a Dijkstra. Oh, wait. We need to do the heat. Let's just do plus s dot heat. That's good. Um, yeah, that's a decent heuristic. And then now this whole thing. You know what? Instead of this list, I'm going to do an option dot when straight is less than 3, dot to list, and then cons those together. Okay, yeah, that filter on that. Then we can take out this else. This is not a member of n. Oh, yes, right. We have just the same direction here. Let me take it out of here. Okay, I don't know if we're doing any deduping. We should probably do deduping. We'll call this directions val. Directions. Okay, so it should run. Am I deduping? Filter not visited states. I keep adding to the visited states. And this is our ordering. So if it's a higher distance to the end and a higher heat, then we don't prioritize that. Okay, not performing enough. Let's just test it on the example. Make sure the logic is good. Day 17, 2023. Where is it? Here we go. Well, hold on. I'm gonna save that as a new file. Okay, let's try this in the example. And it seems it's also slow there. So we performance optimize this, get 1 and 2, and then we should be good. Next states. Oh wait. Oh, that's a weird error. Reference to these are weird errors. I need to restart the server. Yeah, okay, we're gonna do that. Okay, let that run. And while we do, let's take a look at this. So our ordering is that, and we're going to reverse it. So what gets prioritized in the priority queue is the highest elements, right? Scala priority queue. Sure. The highest priority. So if we're using the reverse ordering, or hold on. Priority queue. Oh, what happened here? 132. Okay, so we are off, but it did complete. I might need to adjust my heuristic a little bit. DQ all. So it'd be the highest first. Right, and since we want to minimize it, we do reverse the ordering here. Right? Reverse of this priority queue. Okay, the opposite ordering. Visited. We add all the visited. All these states. Visiting next states that filter not visited. Yeah. Mm, let me think about this metric here. If there's still like a disk plus heat, the heuristic needs to be. The heuristic is optimistic, right? It's adding one for each thing it can travel. This is an A star, not a Dijkstra. Let me think. Disk to end, right? So I'm just gonna print what it is. Visiting. Yeah, sure. So east 0, 0, and south 1, 3. Yeah, and then we're adding the distance to the bottom to that, to the heat 3. And then we do this node next, which had a heat 4 and could still be the best. And then this one, these 2, 5. I think for a given point, what we could save instead to optimize this is the best for a given point, the lowest heat, right? When we get to any point, that should be the lowest heat possible to get to that point. To do optimize by point lowest heat map. Yeah, yeah. I mean, you know what? This straight here could be part of it. Right, if we're moving. Okay, let's read through this a bit more carefully. We're gonna copy worksheet output. And we're gonna full screen this and really take a look. Scratch. Okay, like these are best at each point. So far, like this looks good. We've gone east for 2, and there's 5. East for 3, and there's a 6, 6, 7. I mean, this seems very reasonable so far. Why would it miss? Right, once we get to the end, then this is really just heat. Maybe I should go a little bit longer. Okay, the first thing that hits the end. What is it? Well, I mean, it doesn't matter. All that matters is it's heat, and then you add the number, right? So it's a heat lost so far. It doesn't matter. They all touch the end and hit that same. So like it could be the point above and the point to the left, final candidates, and then you would take the one that has less heat. Jeez, and this is too many states. I need to like dedupe stuff. Wait, how's is it? There are 4-1 with 107. You can't have a 4-1 with 107. Okay, so that's bad. 4-1, 107. Oh, this is straight of 37? This is a straight of 37. We can't be getting up that high either. How? This is only 13 wide. Okay. I'm gonna do it this way. So directions, .filter, and .map, neuter. Area contains pause.move in that direction. And so when straight is less than 3, direction is the current direction is viable. Okay, so we'll take one of these and just calculate next directions. Yeah, directions gets up really high. That's really weird. So when does it get up there? Okay, let's take this as an example here. So we're going to comment out our answer, and we're going to take this state, that next states, for each print line. Oh. And the next state should not include something. Oh, is there a problem? Did we kill it? What do you mean not found neuter? Neuter. Oh, right. There's syntax error. Okay, here we go. S413. Yeah. Oh, okay. There has to be a reset to 0. Okay, when you're moving into another point, it just goes to 1. It goes to 1. So if we're turning left or turning right, it has to go to 1. Now new straight equals new dir equals dir, then straight plus 1, else 1. There we go. I think I lost that when that was originally in the bigger copy paste, and then we lost it. Okay, let's see what answer we get now. 102. That is good. That popped out fast. Let's see if that works. It seems like it might need to be performance optimized. But we can let that run for a bit. Because how fast was it? Oh, I can't see. Yeah, it was less than a second. How much larger is this? I think it's 140. Did we get an out of memory error? Yeah, out of heap space. Okay, yes, we do our optimizations then. And we'll make sure our optimizations work on the example. Okay, point to lowest heat map. Florida. The straight here matters. Mm, And yeah, the direction kind of matters too. And because it's a set, it is deduping. We are deduping the states, but I think we need to like kind of dedupe more aggressively. What if we do like this? I'm just gonna try it with just a pause and a heat. Because once you enter a point, presumably you have the lowest possible heat, right? I mean, the direction and the straight still kind of does matter. Um, we could add that to the heuristic. Oh, but then, yeah, it'd pop up first and you'd have to turn and then it'd be lower in the queue. That's fine. S dot pause to S dot heat. So we're going to do visiting that pause to visiting that heat. Okay, that should dedupe more aggressively. Visit plus equals dates dot wait a second. Yeah, make sure that state has not been visited already, right? Yeah, that will be a lot more aggressive. So visit plus equals dates dot map. Okay, I think that should dedupe a lot better. Hello? Oh, okay, yeah. We still get, oh, we get a 104 now. Okay, that's not good. We're gonna leave it commented as like an idea. S dot pause, S dot heat. What if we also dedupe by direction? Hmm. Let's see. We could add like a second start state. Um, okay, so let's say like you both move into something. Uh, and you'd have different direction streaks. What if you deduped it by like the directions they're able to go instead, right? Mm, yeah. What if part of the state was just the directions you're able to go? Let's consider that. Hmm. Okay. Def viable directions. Um, from a point, and we just want to do this bit here. So we're gonna take. So we have a direction, then we have a straight, and we have a list of direction. And we do this. And now we just do viable. Viable from the stir. It should return a listed error. What's the problem here? Oh, yes, we have to pass in straight. Okay. And we're gonna comment these out, go back to the original. Let me just add in the states. Um, but we have a third idea. So for the deduping, maybe we throw in viable directions. Yeah, reversing that they're reversing that straight. Okay. Oh, nope, nope, nope. What is this? This is originally just not a filter not visited. This original. Um, s dot pause, s dot heat, and viable. Mm, okay, let's see if that brings us back to 102. It should still dedupe somewhat. Is it plus equals states? Oh, right. We comment that out. 103. Okay. Mm, that doesn't work either. Okay, can we just make our states smaller, perhaps? So here we have this. Um, let me think, let me think. Optimization problem here is that states, our visit keeps getting larger and larger. Do we even need to do that, actually? Filter not visited. Because we're not even able to dedupe it. We're just using memory for no reason, right? Yeah, let's just skip that part altogether. That should still give us a, oh, wait. We don't use the visit anymore. Yeah, it should still give us 102, but it's slower. Okay, so that deduping is helpful. Okay, we can't do that. Uncomment that, and that. Wait, why is this taking longer? Oh, this is an example. This used to work just fine. Filter not visited. Add to visit states. We have that visiting state. Yada yada. This is what gave us a 102 on the example before, right? The states like this here is good. Hmm. I guess we could like, maybe we give priority if we're facing south, or yeah, we could make it like a secondary part of the priority. Or we could up our heuristic here. Then we're going to fewer heuristics. The thing is, at some point, we have all of these you may have an idea what the problem is. Um, you can give me a tiny hint. Um, right, like my thoughts here. I'll tell you what I was thinking. I don't know how much of this you've caught. But this is an A star, right? With a Manhattan distance as a so heat is my primary thing, but Manhattan distance is my heuristic. Um, and then I used a set of visit states to prevent like going back into states. This works in under 1 second for the example, but when I go to the full thing, I'm thinking this set is too big because our state consists of way too much, right? That has the position, direction, the straight streak, as well as the heat. So my first idea was to just go by the direction, by the position and the heat. And then I got 104 as an example instead of 102. Yes, I do want to trim those down. Exactly. Um, that's what I was thinking of here was like, how can we more aggressively prune this tree? Because we have too many states. And doing it these two ways was not the right way. Um, and I need to be smarter here. I think I'm gonna do like another filter. So sure, filter not visited. In fact, like this visit state set might not even be necessary once I. Oh, Daniel Souza. Thank you for the follow. Your name sounds familiar. Um, okay, I'm just gonna make sure I get my 102 working again. I don't know. This was this was fine for the example at first. Oh, and we are running on the example, right? Okay. Let's check that that's still working. Um, right. So my first thought was discarding. So this here was essentially discarding if we've already gotten to that point and found like a minimum heat to get to that point. Okay. But apparently, like that's not enough. Like I can check that again, and maybe I can do like some variation of that idea, right? Some variation that's not this one because this apparently did nothing. And well, it got me 103. So okay, this gets me 104. 0.75 seconds. And you know what? Let's print these states, and maybe that can give us an idea of what we should be trimming. So we're going to copy the worksheet output and switch to Scratch. Okay. So sometimes we get to the same point like this here. We've gotten back to this point with 6. Now, with more heat loss, this could matter in some cases. Like when the straight streak is higher, right? Because then this has no spots available to the south. Um, Again, what I could do, so I have this to do. We could do this map a point to the lowest. That might work better than this thing is working out here. So instead of the visit set altogether, we'll do a min heat. So yeah, we're not doing a visiting. Thanks. I wrote that idea up a while ago, and I decided, oh, I'm gonna do this, just modify my set instead. Um, but I didn't do it. I think I didn't do it because I did this, and it was easier to write this. And then I kind of forgot about it while going for this other approach here. So val or map. So we're going to import a collection at mutable dot map and val lowest heat map from point to int. We don't want to develop a default value, but we do want to say lowest heat of visiting is 0. Um, visiting. There we go. And then we're going to do this and filter not, I'm not going to add any visiting. What we're going to do instead is add the new lowest heats. So each of these states, um, or wait, let's phrase this as a filter. So we want to keep these states if s dot heat is less than lowest heat. Like or else impacts value, sure. Um, and then states that for each s val heat. Nope, nope, nope. We're not going to do that. We're just going to do. We've already checked that s is. We're just going to do lowest heat s dot pos equals s dot heat. Okay, let's see if that gets us. Oh, what's this filter now? We don't want that. Lowest heat of visiting. At a point visiting that pause. Okay. Yeah, okay, I did the map. Now the answer is 113. So that's not quite it. Not quite it. Let me check. We're checking that the heat of the state is lower than the lowest heat so far. We could add in direction. Our direction, we could update our heuristic here. It's not just dot pos dot dist. It depends on the direction. If we do like a def h, maybe like that might be enough to get it to work properly. So def h, yeah. So int equals if we'll just do an s dot pop that direction dot match s dot dir dot match. We're just gonna do a match. So dir dot north or dir dot west, and it's s dot dist to. Oh, you know what? I'm going to define this up in here because we pass the end along. Okay, so s dot pause at this to end. And then if it's south or east, and um, well, south east, south or east. If oh wait, this is not just pause this to end. It adds at least one, two, three. It adds two, right? Because you have to move forward. At the very least, you have to move forward, turn, turn to move one, right? So if s dot straight equals 3, oh, it doesn't matter if it's straight equals 3 because you can move to the right or the left. So we'll just say s dot, yeah. That improves that slightly. Oh, yep, it's just dist. So we're going to do h of the state to the s plus s dot heat. Or heat's the thing we're trying to minimize. You still got 113. We are checking whatever, and then we are setting like the lowest heat states as those states. And those states, those low heat states are all what's getting added to our priority queue. So that's good. I'm discarding too many states right now. And I don't know what the deal with that is. Yes, the lowest heat should depend on dir, but I mean, that's what I'm doing. That's kind of what I'm doing partially here in my H. But I should, we could just do like the lowest heuristic value altogether, which then just makes it sort of, so we're using that heuristic in our priority queue. We can also use it in the map. Let's do that. So not exactly gonna be just a heat. We're gonna do plus h of s. The whole thing. Lowest heuristic so far. Well, the thing is that heuristic might not be possible, right? I think that's gonna filter too aggressively. Gonna make it worse. But we can check that very quickly. Okay, it's still 113. Yeah, so adding in the direction. Oh wait, is it running? Why is it still running? Oh, 1. 19 seconds, and it's 113. How did that make it slower? Um, wow. Man, I typed out most of this like right away. I just can't figure out how to optimize it. So we've tried deduping by basically taking the best heat for a point. Oh, wait, hold on. S dot heat plus H of S. Right, we're not just using S dot heat anymore. 115. See, that's changing answers, but not in a good way. So I don't think this is it either. I mean, if that's what you used, then I'd like to know, because maybe there's something else wrong. Like, how do we do for time when it's not even trying to dedupe states at all? And it's just using the priority queue. This is an update heuristic. Okay, that's an add memory error. So at the very least, we need to dedupe these states. This is the only way of deduping states that works, but I need to dedupe more aggressively than that. So I need to find another way to dedupe states. Okay, this works. Let's just check the time on that. 2 plus 2. What if I like removed more out of the state? This took, yeah, these are under 1 second. 150 milliseconds in the worksheet. Well, yes, I basically am doing that, right? So this is my dedupe. Visit. Yeah, we take like the new visiting. So for deduping right here, then once we add that into our priority queue, it has been deduped. And visit adding these states are the ones I've already been deduped out of. Skip some of the visiting values if we're not. Okay, I see what you mean. So like some more aggressive pruning of just this value. I mean, I'd have to dequeue again, and that doesn't. I don't like how that works with the structure of my priority queue or my algorithm here. I mean, skip some of the visiting values if they're not good, right? So you're saying like skip some of these values if they're not good. But I mean, you can also skip them by simply not enqueuing them, right? So that same filter, if I'm right, tell me if I'm wrong about this, but like that same filter that we would apply here, we could apply earlier by just doing it here and then not queuing it up in the first place. So I'm gonna filter knots. Like I need to filter knots somehow. I've tried doing this map. I've tried doing precision plus heat. And I've tried precision plus heat plus some like variable directions. And I need to do even more. I just want to see this again. While I'm thinking, we're just going to run it. I mean, I haven't technically run this before because this now has an updated heuristic function that takes direction into account. Just And I mean, honestly, my state. What I'm getting when I'm trying to include these, so when I do it basically just based on precision and heat, um, then we get the wrong answer. If it's based on all four of these, it's the right answer. So taking out like direction from the yeah, when I take out direction straight from the deduping, it doesn't work. When I take out just straight and I like look at the viable directions, it doesn't work. Right? Like it does do things more aggressively. Wow, wow, wow. 0. I'm just gonna do a quick save here. Just going to add day 17 example. I screw up, sure. Our heuristic potentially adds 2 in. And the thing is, if it's looking south and it has a distance of 3, then depending on whether or not it's in the end column, uh, okay, what I'm gonna do is look at the states that are generated here and look for stuff specifically that we want to take out. So we go back to Scratch and for stuff that we should take out. What if we do it by everything except the straight, right? Like look at this here. These are both at 11. This one here is clearly better because it has a lower straight. Um, and if we were using our map, well, okay, apparently this was visited, right? This was visited, and eventually this was visited. This should not be visited. Um, let's do that. Let's make it everything about straight, or everything about the state except the straight. So we're gonna do this filter. Not we're gonna copy paste this. S dot dir. Yeah. So everything except the straight. S visiting dot dir. And down here due to S dot dir. Okay, and when I do that, it doesn't give me the right answer. There's that +2. What instead of S dot heat? We just did the heuristic function. Um, Yeah, we'll do s dot heat plus heuristic on s. Okay, that's off by 2, right? Which means it's like a turnaround kind of deal. Plus s heuristic on s. S dot heat plus heuristic on s. And we do the same thing here. Using that heat plus heuristic on this is a did that give me a new answer already? Nope, we still get 104. That's not good. Some are still clearly better than others, right? Again, if we did a map of like best so far, and we updated that map as we go. I think we can get this to work with some sort of map. So let's do some sort of map. The best state for a thing. And then we make sure that none of the states are beaten by that, right? So we'll call it best state. Yeah, and then best state visiting that pause equals visiting. Thing it like what if it's south? I mean, you could turn right and go. Like it doesn't matter what the direction is because they're both at 0 straight. Yeah. So we do the states. Filter. Not so if s dot heat plus hs you have to make sure it's just strictly excuse me, strictly better. So best state s dot pause. We're gonna do a dot get, and then we're gonna fold. So we keep it. There's nothing, and then we have best. Now s dot heat is less than b dot heat, and s dot straight is less than straight if they're both facing south. Okay, if they're both facing the same direction. So we do this as an XOR. We'll just do it as in like if s dot dir equals b dot dir, then s dot straight needs to be less than b dot straight. Oh, it's true. And we can keep adding other conditions there. There's probably a nicer, closer, more concise way to write this, but that works. And let's do an and. The heuristic is going to add the direction. right? It's going to add the +2 for the direction. And so h of s was less than h of b. Okay, that should work. And then these become the new best states. So it's going to be something like this. States that for each best state for that position. There we go. What? 114? I want to get this map to work because it'll always be like much smaller, right? So let's look at the worksheet output and find something that doesn't look good. So let's say, I don't know, a point like 2, 2. Do we ever get to another 2, 2? Is that the best? Like, what was my 2, 2 before? Point 2, 2. Wait, we never hit point 2, 2 before? Oh, no, no, no. There we go. Okay, S111, SE112, S112. We should not be, yeah, we should not be going back to those points at all. Right, and that's what's happening formally. We're adding higher heats. And just taking the lowest heat is apparently not enough, right? It's possible to have a state that's better even though it has higher heat. I'm fairly reasonably convinced that that's the case. It can still be a higher state even though it has higher heat. And of course, direction comes into account, but here, south, right, this is clearly better. Okay, so let's go back to whatever it is we copy pasted and look at point 2, 2. And now there's only one case. So that is good. That's kind of what we wanted. Except now like an east doesn't appear. What if we made the map based on the point in a direction instead? Then we kind of wouldn't be able to filter like north and west as easily. Why don't we go to 1? Let's go to a state that works. And in fact, you know what? I'm gonna save this as another worksheet. This is one that only works in the example. And we're gonna go back to this code here. And we're gonna use this for like digging into some of the data. Was it +2 for north and south? Wait, the +2 is for north or west. Yeah, and that's because, uh, that's because, oh, you know what? Technically, they could take a left or a right. If you're facing north, you can still take a right. Yeah, the +2 is because they'd have to turn. But, you know, it's just like the streak is north. And when you go north, you increase your heuristic. So like it'll be deprioritized in the priority queue. And it should not be, yeah, I guess a +2 Doesn't quite work. Like it technically, like it does work, but we're just gonna we're gonna comment this out for now. Um, Actually, we're gonna take that out altogether. We're just gonna go back to s dot dist or s dot pause dot dist to end. And then visit plus plus equals all those states. Visiting. Like if the straight is 0, the direction doesn't matter. The direction only matters when it's 3 and you can't turn in a favorable direction, right? Let's say you're against the east wall and you're already 3 going south. Then it gets a +2. Like maybe I'll write that in. Okay, now this is code that should work, right? This is code that I had earlier. 17 example. But it's apparently different. dq.enq all the states, visit plus states. Okay, the order of those doesn't matter. Visiting that next states, that filter. Those are next states. Wait, this was working earlier. Look at that. Oh, is it just not running? This worksheet's just not running. That's why it hasn't updated. Okay, yeah, there we go. There we go. Okay, let's look back at Scratch. Back. We're gonna start saving 2 scratches now. So Scratch 2. And again, not like this here is way too many states printed. And same point, the direction does not matter all if it's 0. Kind of starts to matter more. So like 2, 2, 2, right? Like we should never get this state. And again, just ignoring straight, just going by heat and position doesn't work. Just going by heat and direction, position doesn't work. Sweet Radish, yes, this is part 1. And I'm trying to performance optimize this a little bit more. Like I have to prune my straights. I get out of memory errors. I need to prune my states more aggressively. There are too many states. And the attempts I do to prune the states that sort of like make sense don't quite work. Right, so this is my original code. This is the first thing I wrote. And I'm not gonna change that. That's the only time I ever really. Oh. So let's open up day 17 again. You get 109 for part 1 example. I get 102 unless I like try to performance optimize it. So the best state for a point. What if we make this a little bit less aggressive? Let's take out this last and. Right, like this gets. So this overwrites the best state if the heat is less than the other heat. And then And if the direction is the same, then straight is less than the other straight. Okay, removing that last bit did make it better. What if I just wrote a really good heuristic function, except here's what happens with the heuristic function. It gives like an optimistic whatever, and that's a good enough reason to have it be the top of the priority queue. Right, but is it a good enough reason to prevent other things from going into the priority queue? No, not necessarily, right? And I'm using this map to prevent other things from getting into the priority queue. Yeah, I'm gonna make my map be from point and heat to state. For a given point and heat. The best state for visiting that pause and visiting that heat. Now, we filter this a little bit differently. So we keep the state s dot pause, s dot heat. If there's nothing, then this is the best state so far, right? Otherwise, we take this b, and now we're not going to use the heuristic function here. We're going to do something like, we can remove these friends. We're going to write it this way. Now let's just do like s dot straight, or let's be very conservative. So if s dot direction is the same as, yeah, we'll just take out just those cases. S dot dir equals b dot dir, then no, then s dot straight is less than b dot straight. Otherwise, we just say it's true. We say it's the new best state. That's not necessarily true. There are multiple best states. Well, it is the best. It is the best given that pause and that heat. Right? So this is already same position and heat, and you have different directions and straights. And you compare the straights, but what if the directions are different? You have to think about if the directions are different. I already had the same pause and heat. So s dot dir dot north or west actually might not matter much. Let's just say L is true. See what that gives us. Stateside. So s dot pause to s dot heat. We'll do some guess and check. That does give us 102. How many states does it give us though? I'm gonna copy the worksheet output. Go to Scratch. I think it's still gonna be too many states. Is it fewer states? Yes, this is the end of Scratch. 300,000 states. That's too many states for something this small. What does Scratch 2 give us? Oop. So Scratch 2. Go to the bottom of that. This is 500,000 states. So it is fewer states, but we need significantly fewer states than that. Um, so let's keep being conservative about what we remove so that we know for sure it's better and it works and whatnot. And what do we have to remove here? So wait, we're going like back to 4.3 for some reason. So why would you have 85 heat at 4.3? Um, what is the min heat actually? Let's look at the text example. Day 17. There are ones in here. Like in theory, you could find a bunch of ones. If we did like a pre-compute of a plain old Dijkstra or plain old A star without any of the straight stuff in it, right? And then use that as our heuristic function for the second run. Right? The distances from any given point. Return a map. Wait. 4.3 east 185. Oh yeah, we can just dedupe that state altogether. Yes, let's take that out. So it's better. It needs to be like definitely better. What if we said else false? Right, we don't even add it unless it's whatever. Then what do we get? Is it running? Oh wait, I think we. Yeah, that's because we are now adding stuff back into the queue if it ties, right? And we shouldn't add it back into the queue if it ties. So we'll just say false, but then I'm afraid we'll lose state. So let's see how it reacts here. Wait, why is that taking longer than it normally does? 104. Okay, so now we don't have all those states. Let's just look at the number of states. Copy worksheet output. Let's go back to scratch. Yeah, open anyway. And this is down at 6,000. That is a lot more manageable. We just need to figure out what state is. Okay, we need to figure out where here we are being. Okay, I need to pee. I'm gonna be right back. And maybe I'll come back with a brilliant idea. Who knows? Okay. Um, so this is better pruning than like my original, but it is too aggressive. 104 is the same answer I get. Oh, honestly, this is exactly the same answer I get when my visiting that I used to when my visiting that I used to dedupe is not the whole state, but just the position and the heat. Um, yeah. Why don't we? I'm just gonna do like a performance test. This will get the wrong answer, but let's see if like this much pruning is enough to get an answer, right? Like we'll, and then we just unprune some stuff and maybe it works. Nope, that much pruning is not enough. So we still have to do more pruning. And then we have to not prune the states that we actually want. Ah, um, I said for a minute, what if I just take like the hashes of the states? And I mean, I already have a hash set. Um, well, I mean, it would still be less memory because it's ints instead of whatever all this stuff is. We could we could try that. So, oh, but we need to be able to compare to what's in there, not just a hash. Well, we go back to the example. Still getting 104, wrong answer, and even once we do get the right answer, this will not be performant enough. Man, this problem shouldn't be this hard. I thought this would be just like, okay, just write the A star and we're good. And I was able to do that. But now I spent like at least an hour. Oh, it's 1:30. Yeah, I spent well over an hour. I feel like I got this in 10, 15 minutes. Yeah, this is exactly the same as if this was just a hash set of pause and heat. If S had else the directions are different. Um, it would be better than the best in the case where like B was pointing north. Hmm. Well, okay, let's say it's north and it's 3. Then, so the only time the straight matters is we can't go south, right? What if I go for that crazy idea that I had about pre-computing a better heuristic? Basically just solving this problem without the straights, right? Yeah, I'm gonna try that. We'll make a new worksheet here. And then def, this will be like a heuristic compute. Heuristic compute. So we're going to pre-compute. It's a map from point to int representing the heat that it would get, right? And then we would not use the normal next states. In fact, like we don't use the states at all. We use the start, we use the end, and we just move. There's no, yeah. So I think we can avoid this visiting map. Visit set, right? Because you use that on states. So val visiting equals just start. Val best heat equals map. Oh, yeah, we'll do this. Equals collection. This is already a mutable map. Map.empty point heat, and then best heat of visiting. Wait. We don't know that. We don't know. Oh wait. That's the heat to get to that point. What we want is given a point. What is the heat to get all the way to the end? And calculate from the end. Oh, what if I did the whole other problem calculating from the end? Okay, so visiting equals end. And then the best heat to get to visiting in this case is just 0, right? Or to get from that point to the end is 0. Val next positions equals visiting dot adjacent dot filter area dot contains. Yeah, the typical. And then we're gonna map. Let's do it this way. Dot map p and we should also filter by best heat visiting. I don't know. I'm just gonna do another like map line like this. Filter area that contains map p to grid p dot as digit. And then I guess once we get all the way to the start point, we're good. So while visiting that pause is not equal to start. And then now there is a priority queue. We still prioritize the least heat bits. Yeah, distance to start plus, no, this isn't ordering on points. Right, because it's going to be a priority queue of points. Ordering by best heat, right? That getter else. Okay. Yeah. Best heat at that point. So P. Um, get get or else, and then P dot heat or heat at P. Honestly, okay, the best point to take is the one with the least heat so far. Let's not think about that just yet. Let's think about what's going on here. So there are these next positions. And why are we mapping this? We take the positions and their heat. Well, honestly, right, these are just the next positions. We're gonna filter them out by best heat. Make sure they beat best heat. Filter. Um, so the position actually has to have like the heat associated with it. So this has a state, which is a point and a heat. So we have our visiting. So best heat at visiting. We have our P. And we have our best heat at visiting plus P dot heat should be less than best heat at that P for it to be a viable next position. And if you queue all those positions, there's no more visited map here. And we take next positions, not for each. Best heat P equals best heat visiting plus P dot heat. Right. And then once we've reached a start, we just return best heat to map. Okay, does that compile? Outdent expected somewhere. Oh, that's in a different worksheet. This one here. Oh, yes, yes, yes. We have to finish doing our ordering for the priority queue. Okay, so when do we enqueue something? We enqueue something after we give it a best heat, right? So for each of these, we add it to the best heat map, and then we enqueue them based on their best heat value here. So ordering by best heat of P. That should work. Visiting, visiting. Oh, visiting is a pause. P dot heat is actually grid P dot as digit. Grid P dot as digit. X positions is a set of point. Let's do less this. Val visiting, that should be a var. Okay. Yes, best heat is a forward reference. All this stuff above that. So you define visiting, best heat, then we give an ordering, and then we use a priority queue that uses that ordering. Okay. So we have a heuristic compute from point.origin to area.botRight. And we can do sort of the same code we did before. Now we'll just add this code here as an example. So def search, except now, we'll just call this heuristic val heuristic. And the heuristic of A star should be like optimistic, right? I need to look up the heuristic conditions. Ordering by heuristic. Sure. Heuristic applied to the state's position. S.pos. Okay. This should give the right answer. Wait, 112. It does not give the right answer. That is a bad heuristic. If we change this to like s.pos, pause at dist to end, plus s.heat, it becomes 102. Okay, let's add this a little bit more. So this is the heat heuristic. What if we did s.pos.dist and I'm just doing so much guess and check, it doesn't really feel good. 11. So that didn't work. Why would using that as a heuristic not work? Let's say, okay, best heat of point origin. Or what is it, heuristic? And we could do a draw. Area.draw. Oh, we can't quite do a draw, that takes characters. Make a draw that does a string. Draw S. String builder, add 1. I guess we'll do like whatever the string is for each. Wait, there's an F function. Oh, right. Yeah, so we'll do like an f dot for each c. Then we do, wait, f applied to the point xy. For each c, do sb dot add 1, right? Okay, now we can draw this. Area dot draw s. Okay, this takes a function from a point to a string. And we're just going to do if let's define the h val h equals heuristic at that point. H is less than 10. Then we do a string. I know there's a better way to do this, but I can't think of like the string format right now. I'm just gonna do this. H is less than 100. Then S. Doesn't have that. Here we have two spaces. Else SH, sure. It has a problem with that? Be good. Oh, we need then. Not arrows. Okay. Let's take a look at this drawing. Maybe. What is this returning? This whole thing should return a string, right? That we then print. Okay, no such element. E not found 0.33 in the heuristic. Oh, does this not cover all of the... Interesting. Okay, heuristic dot keys. Yeah, I'll just do keys dot size. 165. Area dot points iterator dot size should be the same, 169. So there are some missing points. Okay, so it's not as soon as you hit the start, but you do have to keep going. Okay, so we'll keep fizzing stuff until while best ETH.size is less than area.size, right? Now you get 169. And now you get 111 down here. But at least we can draw this. Let's draw this. Okay, this is what our heuristic looks like. Oh, a lot of these are kind of way too high. Wait, no, 78? How is 78 the best way to get to... You'd add 78 heat to get all the way here, is what we're saying. It's like, here you'd add at least 77 heat. 77 heat. This must be a 2. Okay, this might be a dead-end approach. I think I'll leave this code here. I could revisit that. But like basically I need to do this to make it work. 102. And again, even when I do that though, it's still too many states. Let's look here. It skips us 104. Wait, there's a problem with it right now. else here, else true. Wait, true gives us 102. But how many states are there? Copy worksheet output. And we're gonna switch to Scratch. Wait, what happened to Scratch 1? Yeah, whatever. Yeah, 300,000 states. That's too many. Wait, really? Is that what we got from this? Copy worksheet output. Go to Scratch. How did it get so high? What's the last thing we did? That's true. We're basically saying, yeah, put it in. And if it's a high-ish, put it in. When it's false, we have 6,000 states, but we lose one of the wrong states. Why is this one of the last ones we look at? Missing state point 1010, and then we get 99. I guess we popped something out of the queue then that has hit it. Let's see. Point 12, 12. No? What is the bot right point? Area.bot right. Oh, 1212 is the last. Okay, so let's look for 1111. Point 1111. There are two states, one at 100, facing south with whatever. Make this bigger. Day 17 example. Right, you have to add 3. Go south further from here. And let's look for the other one. 1111. This one, 98. Wait a second. S1, 98. We walk into 3. So we visit this state, right? That should. Oh, wait. That's not 11. That's not quite it yet. Let's look at 11, 12, and 12, 11. One up time. Hey there. We are still on part A. I'm trying to performance optimize it, and every time I do try to do my tree pruning, I end up with the wrong answers, like 104 on the example. I can get 102 on the example, but then I have too many states, and it doesn't work on the actual problem. So that's where I am right now. I've got something that works, and then when I try to optimize it, it breaks. Yeah, I'm trying to prune my search state. I've tried several approaches to doing that, to like pruning and deduping, etc. Yeah. So let's look at 11, 12. 11, 12. So south to 101. So that adds 3. That's probably the state that gets me there. Does a 12, 11 ever get added? Okay. I want to look at the states that I should be getting. Scratch 2 should have it. Scratch 2. Okay. Right, so this has like 50,000 states. Wait, does it have the right answer though? I don't know where exactly this came from. Let's look back here. The answer is 102. Okay, and this is done for what kind of code? Oh yeah, just my most basic priority key code. Like 5,000 states. And what should we get for 1112. 1112. Let's do 99. That makes sense. That's probably our thing. And S2100 is in there. I've taken that much out. I could check. Let's just go back to this. So this is my basic approach. I'm just going to do a little optimization on it. We're going to call this X3. We're making so many worksheets. Very basic optimization, and we'll just dedupe some of the straights, right? And we can do that by filtering not in a few cases. So we have our state. So visited S1, or let's do this. For 0 to S dot straight, we'll just do a map. And we will not add the state if there exists. Yeah, this is an exist check. Exists a straight such that visited contains s.copy with that new straight, right? Yeah, so we do like up to 3 checks there. That should still get a 102. It should be fewer states. Copy worksheet output. Go ahead, scratch to paste that in. Wait, 28,000? 28,000. No, didn't I have 5,000 before? What code? Okay. With this code. Really, with this code? I'm not sure I believe that. I'm going to copy paste this. So I'll go to X3. We'll save this as X4. Worksheet output. And we'll just paste it in here. 50,000. Yeah, okay, this is fewer states. This is fewer states for sure. What's the difference then? Between this and our basic. Because it looks like our basic. Looks identical. There's something happening below. Oops. I don't see the difference. And yet this gives us 50,000, this gives us 300,000. $50,000. Yeah. And this, next copy worksheet output. Oh, also 50,000. I don't know where that 300,000 came from then. Okay, forget that. We're going back to x3. Um, okay, and what we've done here was dedupe some of the states, the straights. So we'll copy this worksheet output, go to Scratch. Oh, and we had 28,000. Oh, 28,000, not like 280,000. Okay, yeah, that's still too many. So our approach now here, we're going to do like some of the same flips we've done before, but we're going to do it very carefully, very incrementally. So let's find stuff to dedupe. This is still getting the right answer, yes. 102. You should make sure, for example, like 0, 0 should never show up again. 0, 0 out of 191. Yeah. And deduping that heat out has been difficult. What if I just loosely deduped it? So what I've done, if I simply take the best heat, then it won't work. So what if I make sure like it's within so and so many of the best heat before it can be added to our priority queue? Um, yeah, let's see if you have a best heat approach somewhere still. Okay, here's our approach using best heat. And one. Oh wait, best heat? Oh, yes, yes, yeah. This is not our approach using best heat. Maybe it's back in our main. Day 17. Okay, here we're at 104, and we did a best state for given that position and that heat. Yeah, we'll say the best heats. Let's say the best heats for a position, but then that's not necessarily. So let's say this. Let's overwrite x4, or you know what? New file x5. It's going to do a map of the actual best heat, but we're not going to filter strictly by that. We're going to filter very loosely by that. So where is this? We have the lowest heat. And lowest heat at visiting position is that. We can take this out. And we filter on the states. That's that heat. So we can only make this, we can only consider this. Let's add like, let's just do like +5. We can only consider this state if its heat is within 5. I like saying it this way, is less than 5 plus the lowest heat, right? And this won't be as aggressive, but it will do. The lowest heat will become the lowest of either. So we're going to do like a lowest heat, getter else, min s dot heat. And our ordering, our priority queue ordering still seems fine. now we're putting less stuff into that priority queue. No element to remove from the heap. Oh no. Because we're not adding enough into the heap. We prune, this somehow prunes too aggressively. Let me think about that a bit. Let's see what's actually printed out. Oh, so we had the first one. Okay, so we should keep all these states, right? Print line states.size. We get a 0 the first time through. Okay, next state's filter. I'll make sure that s.heat on that next state, lowest heat. Oh, wait. Oh, hold on. Lowest state.get s.pos .get or else in .max value. Oh, I mean, that's the same thing. Let's just do print line. Must be lower than that max value. And then we'll do like this s.heat. See what it prints. This is a get or else. Right. Or must be lower than whatever. 3 must be lower. Those are both lower. Is our filter just written wrong here? Is this like a filter not? Wait, but it is lower, right? Let's take this out. And 3 must be lower. 4 must be lower than that. 3 must be lower than that. Oh, wait. Plus 5 is on the wrong side. Okay, there we go. 114. I don't know, let's do like a plus 10. 114 plus 20. Wow, okay, this approach doesn't even work if it's super lenient. Okay, so that's not quite the way to optimize this. So we had been looking at this, or x.worksheet, this one right here. We had been looking at this and the output from it. And we were like, okay, 0, 0 is an example. This is the same code. 0, 0 is an example that appears too many times. So we're just going to filter that out. Let's go back to x4. Like this was working, but this had fewer states. We did a little extra filter on this. No? Was it x5? I have too many files, I can't keep track. No, this is S5. Oh, and I don't like this, by the way. I should just do dist. s.pos.dist and yeah, H is not used. 116. Where had I done that? Okay, we're gonna look at these one by one. Maybe we'll start killing some of these. Um, it's definitely not this. Oh, is it? Is it this? No, it's not this. We done one little optimization, which was to check not just for, not just if it's been visited, uh, right? Like we decreased the number of states significantly that way. You know what? We can do this by looking at Scratch. No, Scratch 2. Okay, this one here has 50,000 states. Where was that? We just added an extra filter on visiting to make sure all the other states. Oh my god, I'm a mess. Okay, look at example 5, visiting that filter. Yeah, except we've done it on a set. That's our latest attempt. That doesn't quite work. This isn't it. I mean, what if we do it here? Let's just do it here. Let's just add that back. So, we're gonna filter not visited. We're gonna filter not based on P. This code right here, 0 to s dot straight. Let's just search for that code. Um, so cd source main Scala 2023. Find dot name xarg cgrep, and what are we looking for? 0 to s dot straight. Oh, yep, just find dot is good. Type is a file. I must have deleted it. Rep day 17. Okay, just a day 17 worksheets. Xargs grep. Um, Zero 2 x3. There it is. Okay, so let's go back to that one that was just open. Make sure it still works properly. Filter not visited. And let's go back to x3. X3. Okay, here it is. So this, the output of this, was indeed smaller. 28,000 instead of 50,000. But what we want to get rid of here, 0, 0, appearing way too many times with higher heats, right? And we want to figure out how to get rid of those two. We could look at the best heat. So we could do like in conjunction. Right syntax. I think let's put the dot filter down there. Okay. So let's add another filter. I think I'm just going to add the map as well. So val best heat at a point equals map.empty point int, and then best heat using a pause equals 0. Then we're gonna add that to the filter here. So our state, s dot heat plus 20, sure. Okay, we still get 102. That's fine. Um, let's prune that like 5. And let's count the states. 27,000, that's better than 28,000. Let's prune that more aggressively. Plus 2. Wait, is it the same? It should be removing out all these extra 0 zeros. Yeah, a bunch of those extra 0 zeros are gone. Okay, that did prune it out. That apparently did not help much. Right? If we go to X, I'll just comment that out actually. 27,893. If we add that filter back in, and this should have multiple like 0 0 cases. Oh, it doesn't. It doesn't. That's nothing we needed to do here. Okay, what does need to be done then? Let's just look at a point like 3 3. 3 3. There are 319. That is way too many. So 22 22. Oh, interestingly, we had S2, and I guess we eventually got this S1 22, which is better. East 122, South 123. Okay, yeah, we're getting a bunch that are like by 1. Okay, so this will take out some. Let's just take it out altogether. Do we still get 102? We still get 102. Let's copy that worksheet output. 27,893. Interesting. 3 3. Nope, that filter's doing shit all. So the state is only valid to add to the queue if state's heat is less than the best heat for that position. Best heat, best dot pause. No, we're not doing any of that. Dot for each. So we have an H, and we can print. We're gonna do a little bit of debug. If there is a best heat, S dot heat must be lower than H. Let's see if that line gets printed. For each is not a method. There we go. Wait, best heat. We're gonna do dot get here. There we go. That way is an option. Okay, take a look at that. Must be lower. That happens 300 times. We have a check like that. Okay, but now let's look at 3 3 again. 319. Why does it not happen here? Right, this is 0.33. These are both 26. Well, I guess this one happens first. And then we eventually find S1, which turns out is better. But surely we find East 1, S1, East 125. Wait, if we already had East 125, then how did we get 26? This here is supposed to get that out. Oh, hold on. Fizzing state. So from 0.33, we have visited state 0.33. So we add a bunch of things to the queue. And then we should add a best heat. We're not updating best heat. That's why. That's why. Yeah, it's only taking out the zeros. Okay. Yeah, yep. I missed that. Let's do it before the NQ. So states dot for each S best heat. There we go. Becomes a minimum so far. I expect that to go up. But my number of states should go down. 500. Yeah, it's too aggressive. So let's put S dot heat plus 5. Hmm. 10. Okay, we're pruning this stuff out. And apparently pruning all that stuff out is too much. We pruned something that we shouldn't prune. Yeah, let's just print out the whole thing. Copy that worksheet output. Okay, now we see the whole state of the things we are removing. Right, this has heat 104. That heat must be lower than 102. This could actually be good, though. Oh, no, 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 no. If we make this, like, ridiculously high, then it should just go back to, like, give me the answer 102, yes? I mean, if we remove this altogether, it'll give me the answer 102, that filter, right? S dot heat plus 100 doesn't make a difference? Or makes a difference? How? 108 must be lower than 103. This is kind of crazy because we added 100 to that. 9, 10, wait, 108 plus 100, right? Oh, right. So those weren't getting filtered out. Why don't we print this message only when if s dot heat plus 100. So this, I just want to see when this is ever happening. Less than h. Okay, so this only shows a pruning that gets done by this very, very lenient prune. No pruning is done. Must be lower, right? No pruning is done. No pruning is done is the same as just doing no filter at all. But no filter at all gives us 102. So why? If my best cost to 1520. I don't know what my best cost to 15 is. I mean, I could do that here. I could do that by doing point. You mean x is 1? and X is from the left and 5 is down, 5 from the top. I don't know if we have like an off by 1 there, but like 21. I get 21 for something that prints out the correct answer, 102. So like we might have like an off by 1 there. Wait, sweet radish? Are you still trying to get, you're still trying to get part 1 at work, right? Anyway, for reference, that should be 21. Okay, so this filter does absolutely nothing. And yet when we comment it, when we uncomment it, we get a different answer. And it's not doing anything. Right? I mean, we can put this in if, whatever, then print line filtering. Right? It's that same condition. Filtering. And apparently it is filtering. It is filtering. And yeah, it's not pushing this message. It's less than H. Oh, wait. This is accepting. This is accepting. So accepting a state. Oh, I might just have Boolean blindness. That might be what's going on here. Otherwise, we're filtering. Else. Yeah. Okay, let's see what gets rejected from here. Too many getting rejected, apparently. So rejecting this, and it didn't even wait. S1 has a heat of 6. I think we should also print because of heat. And we do like best heat dot get for that position. Rejecting 110 because of some 103. Rejecting this 110 because of some 105. Oh, wait. Am I doing this the wrong direction? Should this be S dot heat plus 100? Oh, this is the wrong direction. It should be like minus. Now this will reject nothing. Yeah, okay, Boolean blindness of some sort. Now this should be too much. That gets us 116. Let's just do like -2. Oh, wait. -2. Okay, we get 102. Okay, now like we know this thing works. And look, our number of states is much smaller. It's much smaller. Let's take our print lines. We don't need that. We can rephrase this best. So we're gonna do like best heat dot get s dot pause We filter it, we keep it if for something that exists is greater than, let's say it this way, s dot heat is less than it. Yeah. Okay, so it's valid if one that exists. Yeah, great. Will one still give us the right answer? Nope. We need a leeway of 2 on the heat. Okay. Um, I'm gonna take out my print lines. I'm just gonna try this on the main thing. This seems warm enough. 969. Okay, that has taken too long. And it's too high. Okay. So 969, too high. Okay. Let's be a little bit more lenient. Let's do a -5. Let's see if we still get an answer. 959. Uh, let's see how far we can make it go while still being able to run it. 959 seems like it. Okay. I have to wait. 11 seconds left to wait. But yeah, this 10 seems to prune enough. 5 seems to prune enough, right? 5 still giving me the right answer. 959. What if I just typed it in wrong? Okay, there we go. On to part 2. Okay. Uh, so now we have ultra crucibles. It needs a minimum of 4 blocks in that direction. Okay. Well, we're gonna make this like a search too. And we're gonna use a different state. Because now our variable directions are still the same. Do they still have to move a maximum of 10 consecutive blocks? Okay. Oh, Evgenus, thank you for the follow. How did I do on that? Oh, wow, I still got 3,000. Jeez, I took so long, and I still. Okay, that makes me feel a little bit better. Um, yeah, I'm ahead of the person I'm trying to beat. So there's a thing. Um, so we're just gonna call this state 2, and then we'll define a variable 2. So minimum of 4. I'm still gonna increment by like 1 at a time. So if straight is less than 4, then we just do the whole thing. We're gonna do that for now. Else if straight is less than 3, then we do this thing, turn any direction, or less than 10 rather. Less than or equal to 10? It's a maximum of 4 of, no, just less than 10. Um, Otherwise, you must turn. Yeah, this is viable 2. Um, and now I'm going to have to add in an extra state in the beginning, facing south or facing right. Yeah. So then, oh, you know what? It's not even going to be based on just variable anymore. I'm going to leave this to be to handle just that if we can turn. Yeah, but then here, um, so if there is a new direction, so new straight, if there's a new direction, the new position will not just be in the direction of the new direction. If the new direction is different, so if new dir is not equal to dir, okay, then we're gonna move for val new pos equals pos at move dir in a new direction by 4. 1, 2, 3, 4. And then val new straight equals 4 because we've already moved 4 in that direction. Alka, hi. Thank you for the raid. You gave up. Well, I got part 1. I finally got part 1. It felt like such an easy problem, and then it took me way too long to prune out my states. What I finally started doing was just like whittling away just, like just the minimum. I added some leniency to my whittling. Um, so I did basically like a heat map. I don't know if this is too much spoilers or whatever. Stop me if it is. I basically did a heat map at the lowest heat, and then instead of just checking, well, I'd filter my states as about to add to the queue. First, I would check that they were within some factor, not some factor, like within 5 or within 10 of the lowest heat. That way, my states wouldn't explode because it didn't. You could have 2 different states that are at the same point, and one has a heat that's like 5 higher than the other, and still ends up leading to a better outcome, right? And I don't know why. I can't explain that. All I know is that adding leniency is what finally helped it work. Um, oops, negative. Okay. And we have our new straight. And then we have code like this. Yeah. So new pos, new straight, new dir. Okay. It's all good. Oh wait. It's not just heat plus, so new heat's gonna be different too. Now new heat equals all of these. hold on, hold on. I do have to do another filter on here. Do you want to know what the part two is? Yeah, that's fair. That's really understandable. I'm just hopped up on too many of these. Oh, I have a hard time sleeping after this. I'm gonna have to like down a whole bottle of melatonin. Yeah, so in the update, you have to move a minimum of 4 blocks, maximum of 10 consecutive blocks. This whole thing. If new direction is not equal to direction, then we actually have to do this here might fail. Um, yeah, we'll keep the same viable, but we'll check. Um, we'll check if it's like less than 4. I mean, if we basically go like right away to 4. Basically go right away, moving 4. So we're never gonna have like less than 4. It's just that when we make a turn, how do we write this nicely? I guess I could just add the filter in here. It's gonna be messy, but you know what? It's going to work. Infamous Quiet. Thank you for follow. Okay, so we're just gonna do an extra filter here. If D equals dir, if our new direction is that, then area that contains pause that move in direction D or 4. So it has to be possible to move there. Otherwise, we just check the area contains the forward direction. And now we had this new direction here. And if new direction is not equal to this direction, then we have all this extra stuff. New straight is 4. We just move straight to the whatever. New heat equals, I guess we do the points along the line from pause to new pause. Get all the heats of that, not from the current pause, pause that move in that direction to new pause dot points dot map grid dot as digit dot sum plus the heat so far. Okay, that works. That works. So now we have new heat, and then else it looks much like it did before. Just moving forward. New straight. New straight is just going to be straight plus 1. This new direction equals direction in this case. Okay, so we have a way to get the next states. Now we need to apply the next states here. I think we use the same state class. We'll just do fine a new state next states method. So we'll call it next states 2. We'll move viable 2 up here. Yeah, there we go. And then here, I think well, let's go back to the example. Make sure we can work on the example. Looking 102 because we're not using new rules. So now we're going to do next states 2. And see if things change. Right, that's the only thing that needs to change. Next states 2. I think I need to add extra states to here. Well, okay, from here, yeah, we can't just turn left and right. Let's say our start is like moving to the right by 4. Or you know what? Let's say our start state already has 4 and it's allowed to move. No, 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 no. Okay, we'll just define them up here. Val moved east, and this is a state. Start dot move or dot east by 4, and then there dot east we have 4, and for heat we have the line from start to start that move 4 map grid sum, whatever, that's good. And val moves south. Okay. And my starting state, let's see, let's do this. Val visiting equals moved east, moved south, min. Oh, you know, we're just gonna do a sort by heat. So visiting, and then we have the other one. So visiting can be the one with the lower heat. And we're gonna enqueue the other. So visit equals the set that we're visiting. And then pq.enqueue the other one. And then visiting that pause equals visiting that heat, because these have both been added in. And best heat of the other one, other.pause equals other.heat. Sort by, oh wait, we want to make this a list. And then we're gonna match against that list. Here we go. I meant to val visiting. Okay, these are vars. Okay. Unset local variable. Wait, what? How? You know what? We're not gonna mess with fancy stuff. We're gonna do list min by heat. And that becomes visiting. And val other. Oh, it knows. Fine. Max by heat. Okay. That's more like debuggable. And oh, we didn't actually call search 2. And 2 equals search 2. Okay, we have an issue with this. String index out of bounds. Wait, string index out of bounds. Oh, it's part of our grid. Okay, so that means in here somewhere, we didn't look at the four ahead are at extension somewhere inside next states 2 under list.map, vector.map. Okay, next states 2. So area needs to contain. How does that move in that direction? 1, 2, 3, 4, right? Else area that contains pause that move D. If it's in a different direction. Viable 2 going on here. If it's less, yeah, this is just looking at left turn, right turn possibility. It's not even looking at the less than 4 thing. So we do that filter. We map, looking at new direction. I'm just curious if you need the actual. Yeah, you do need to edit that. Pause that move. We try to get the new heat. Grid of that point. This is where it's happening. Line from pause. Okay, we're gonna print line. This line exactly, and all the points that come from it. Okay, let's look at our debug. Point, -1.8 to 0.9. How did we get to -1.8? I think I need to print line a little bit more so I know the context of that. Here we go. So print line. So moving from pause, yeah, to new pause. Okay, last thing that happens, we're moving from 0.8 to 0.12. So we're moving for the east or to the south. And then vector point -1.8. You know what? My line function is no good. I'm not gonna use line. So val covered points equals third match base third.north. Or wait, did we do this for all of them? I think we're just gonna do this for all of them. Yeah, so let's do a match exhausted. Okay, so we're gonna have pause dot east and then moving forward in that direction. Dot x new pause dot x, and then we map that x. We're gonna do this. We're gonna make this until and then do like x plus 1. And pause south.y until new pause. almost, except south. Wait, is south adding? Yeah, south is adding. Okay. I negative 1 map x minus 1. Okay, that looks good. Okay, so we had the covered points. I'm going to comment that out because I'm kind of fond of it. And now we have covered points map. Okay, that's a silly thing to have to fix. But here we go. We get an answer of 14. But for the main example, we follow this path and 94. So we're not adding enough heat. Oh, I'm going to remove this filter for now. Just looking at the states. Because that filter might be too aggressive, right? And it seems like nothing changes. Yeah. Okay, let's take a look at what we're visiting. I'm going to comment out ants 1. Okay. 4, 0, 12, 8. And then, oh, wait, we just get there? 4 to 0 with heat 14. Then we get to 4, 4. And heat is still 14. Heat's not increasing. Okay, let's look at our new next states function. So new heat. We take all these heats, sum them up, add the current heat. And then if we're going straight, it's the same old rules. Yeah. Same old rules. But the heat should be increasing. Let me think about this again. So let's open up that scratch. So we start by visiting 0.40. And apparently, like we add some values. So this starts with like a heat of 14. Right? That's just our initial state. And then we get a bunch of new states. I'm going to add what we're enqueuing. So let's do that here. We'll do like states for each, and then print line and queuing. Look at that. Wait, that doesn't seem to have changed at all. See again? No. Well, I mean, it can't be empty. State. We do stuff. Oh, and this, I'm going to keep using this heuristic here. For now, that seems like it's probably okay. Oh, wait, did we add it to the wrong place? Yeah, okay, we added it to the wrong place. Add it down here. Black Panda, yes. Oh, Chi Chi. Thank you for the raid. Welcome, welcome. How'd your night go with this problem? I am working on part two. Part one took me forever to figure out how to prune because I would prune too aggressively or not enough. Like I could get it to work, but then it'd be too many states, and I'd start adding different ways of pruning it, and it would not work. What I ended up doing was just doing like pruning, but I gave it a little bit of leeway, and then that's what made it work for me because it's still pruned, but not so aggressive that would catch the wrong things. I don't know what like the exact rule would be, but like I did a heat -5, basically. Oh, he leaderboarded for part two. That's great. How long ago did you finish? Just curious. Because I was surprised that like 2.5 hours in, I was still like 3,000. A lot of people must have, maybe a lot of people gave up. Okay, so we're we're debugging our part two and just making sure like we can get the basics working. So what are we enqueuing? We're only enqueuing 4.4 and 4.0. We never enqueue 4.8, but the heat should be increasing and it's not. So 4.4, we need that to be increased. Honestly, for all of these. Wait, enqueuing 0.4. We should already have 0.4 in the queue. Looked like 17 minutes. All right. Oh, Eric Wassel. Did you come over with a Chi-Chi? Yes, I see that. Oh, the 2019 int code problems are so fun. I started doing that as warm-ups between Advent code problems last year, and I've done most of them. I think I stopped on like 19, and then that's sort of when the season ended. But I want to just like do those over again now that they've had time to forget them because they're fun problems. Okay. So our next states two is not increasing the heat. New heat here. Covered points at map, blah blah blah. You get their old heats. You get the old heats of all these points. Let me just make sure like that's not empty. Covered points. Why are all of these empty? A bunch of these are empty. Okay, I think we just had the wrong directions here. So if our new direction is east, then east.x until we pause. Well, hold on. Our cover directions are not always empty, so we can use that debug output to determine which ones are wrong. Wait, covered points are always empty. Okay. That would explain it right there. So east x. Oh no, x should stay the same. Wait, you're moving east. Okay, yeah. So the position to the east. This can be 2 to the new pause. Okay, so the position to the east. Martha and Joy, thank you for the follow. The position to the east all the way to the new position. We take all those x positions, right? And then that should be negative to positive, right? Like moving east increases x. I'm going to print also the direction that we're moving. I think like east certainly seems right. And if it shows up here, oh, nope. Only ever moving east and south. Um, so some, excuse me. Oh, don't stop on 19. 21 is one of your favorite puzzles ever. Okay, I'll go back to it. But I kind of want to start that over. Chi-Chi, how far along are you in the encode problems? One where like we're factoring between days mattered and could give you like a leg up. I'd like another series like that. Day 7. Yeah, those are really fun. Okay, so east covered points. Um, you know what? Let's print like pause and new pause. Um, so print line. Uh, moving from pause to new pause. Oh, hold on, we have a syntax error here. Okay, so that should evaluate Apple worksheet output. Okay, so we're moving from 40 to 0.44, right? So we're moving to the right. So this should be like 41424344. Wait, 40 to 44. The direction isn't matching up, is it? Oh, hold up, hold up. We have two directions in scope. This has to be new direction. Uh, okay. That's the worst kind of bug to have. Okay, so now we're getting something. Yeah. So that part, adding the heat, is happening properly now. Now we're getting an index out of bounds exception. Okay, it's probably something similar with a direction. Um, okay. So we do filter on our viable things. And this D, if it's been in the same direction, oh, we need to flip these two around. So if we're moving straight, then you just need to contain the forward point. Otherwise, there we go. Moving straight is just forward. Otherwise, returning, then we need to make sure we have D4. What is this? GitHub Aneurysm 9 VM challenge. In the core. Oh. Okay. I'm gonna do this challenge. I know you wrote it, right? Like I've seen it in your blurbs and blogs. And it's similar. Do you want another puzzle like that? Hmm. Fair enough. It took forever to build. Yeah, I didn't read. You know, I think I looked up Cinecore at some point. I didn't realize it would be okay. I'm totally gonna do Cinecore, and I'll have a lot of fun doing it. Oh, hold on. It's a company that hosted is gone. Okay. Cool. So what happens now? We have ends to wait, we're still out of bounds. Oh my god, a bounds check. This bounce check should be so easy. It's because this code is messy. And that's because I was adapting it from part one instead of just like rewriting it. Okay, I will definitely do both. Um, no, let's look the output of this. And let's see where exactly it went wrong. Oh, we can't see it with what we're printing. Okay, let's just take stuff out. Um, oh yes, we've disabled some of our filters for now. Hmm. What did we end up fixing? Oh yeah, just changing the direction. So this should have been posit move neuter, and I think this would end up working. So I'll think about uncommenting that, and that will replace these 4 lines of code. Okay, let's see where we're getting the out of bounds. Right here. Vector 241404 -14. I should be checking that all of these are inbounds, or rather, all I need to do is check that the last one is inbounds, and I think I do that. Right? That is exactly this code here. Area that contains, right? Like this D is going to be like a new dir. In fact, I'm going to rename it to that. Hmm. New direction equals the current direction, then you can just move forward and we check that that is in bounds. Otherwise, pause that move in that direction 4 times. We just check this move function here. It's going to be one of these repeats. Copy X. West repeat is minus N. East repeat, sure. South repeat is plus N. South is positive and is negative. Okay, that's fine. You're gonna go stare at a wall for a bit. Fair enough. Mm. Sometimes I feel like I'm staring at a wall doing this. Oh my god, it's 3:17 a.m. It's so late. Is today's hatch hard? It doesn't sound hard. It doesn't feel hard. And honestly, at this point, I'm just so tired. I'm screwing up on like basic stuff. I'm not properly filtering for inbounds. So we need to check that the area contains pause that move in a new direction by 4. Uh, let's print what we're checking here. We're gonna say like checking bounds for neuter, right? And then let's do, oh, that's a print line. Then we got print line potential new pause is that this same code here that I have below. Okay. And let's look at the worksheet output. Potential new position. There's -4 that doesn't end up showing up. So this last one here, S dot covered points, -1, 4, moving from 4, 4, moving from 4, 4 to 0, 4, and we ended up going past it. Okay, that's the issue right there. And I think it's specific to like south then. Um, and then potential new pause is 0, 4. Yeah, and 0, 4 was in bounds. I think we uncomment this line of code here. So we have a line from position, move in the new direction to the new position altogether. Yeah, that is the new heat. We don't have the covered points. Okay, so we're back to not erroring. And we get 132, which I think is wrong. It's too high. But at least like that's working. Um, let's just make this a little bit less noisy. We don't need these anymore. Confident of our balance check. And moving from pause to new pause. We're not actually moving at that point. I think it suffices to look at the states that we are covering, that we're like in queuing and whatnot. So we're just gonna delete those and let's print the state we're visiting. And what ends up being this path? So we start by visiting this. We enqueue this state. I think I should remove my enqueuing checks. I just want to know what states we're even considering. And this enqueuing is just going to be like duplicate because we enqueue everything that we eventually visit. Okay. I kind of wish I had the path so I could check if like the path is the same, but my heat calculation is wrong. But we'll get there. We'll get there. Okay, so 14. There's this state with 15, which we end up visiting next. So these are our first two states. And then we're visiting 4, 4, apparently from here, right? So there's two ways to get to 4, 4. This one is not getting filtered yet because I haven't added that filter back in. It's currently commented. And I'm not even sure how much leniency I should have, right? Like this 36 heat could very well be a better path because now we're able to move south further or east further, right? Interestingly, where are all the fives? Wait, 0, 12? Do we have like an 8, 8? Do we have an 8, 8? Let's write this example. Move right, right, down, right, down, down. Oh, this example doesn't have any like moving less than whatever. I like the idea of checking out this other example here. Yeah, no cases here show up where we move to 5. And it seems like that has to be the case here, right? If you ever move like 9 points and you can't move right, I guess you can do like halfway to like 6, down, 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 and then the other rest of the halfway. So that's like a possibility. But still, why don't we ever see a 5 or a 6? So let's see, comma 5. Do they even get enqueued? Um, Forget about visiting. We'll look at what's being enqueued. Okay, comma 5. Nope. We have 5 comma. No, that never gets enqueued. Okay. Does that state get generated? So we filter not. So we check visited for any straight less than. It should be 4 to state, so straight. Filter not. We're making sure that no state exists with a better straight, with a lower straight. And since that's going to be like a minimum of 4, we should do that. Not that that will change anything. And that seems fine. So let's look at next states too. So we should have multiple new directions, right? So this is a case where new direction is the same as the current direction, and we're creating the state for that. Let's just say hello. Let's see if we ever get there. Apparently we're not. Yeah, we're not getting there. So we're filtering out the same direction altogether. So let's take a look at our viable function. If straight is less than 10, if straight is less than 10, we should still have forward direction, right? And then we also get left and right. It seems like we're only getting left and rights. Okay, let's just print whatever the viable stuff is. Viable. Do a straight. Viable. Oh, wait. We actually need an interpolator there. And this will just be like a list. We should also print our current direction. I'll just print that direction. And I'll just add a space. Okay. So we're going east. We only get north and south. Let's print the current state. Print this. These are like silly bugs that we have now that I should be able to catch faster. But okay, so we have state 40. We're looking east, north and south. North and south are viable ones. Is this just like Boolean blindness here? So straight is less than 10. Straight is indeed less than 10. Then we should return this direction, the current direction, east, along with north and south. Are you seeing this? So this state here which has east and a straight of 4, should return north and south and east. Right here, this would be east. Um, Viable, straight. Okay. Atios. Welcome, welcome. Thank you for the follow. Okay, so east, west, north, and south. Has anything changed? Anything viable? No. Oh my god. I know what it is. Oh, I should have changed. You know what? I should like start a new worksheet instead of keeping the old code in here. I'm not using viable 2. I'm just using the old viable. Uh, okay. That that is a lesson learned. I should really just copy into another worksheet if I want to keep old code around. Because I'm not reusing that old code. I'm just like keeping it there for reference. In fact, I'm gonna delete. Um, okay, I'm gonna save this as a new thing. We'll call it 6. I'm just gonna delete all this old code. Viable. I'm gonna delete next state. I'm gonna delete the first search. Yeah, I made mistakes where I edited stuff in the first search instead of the second search. And actually, our answer is 96. And that's what we should be getting. No, 94. Okay, we're getting close. So we don't need this hello anymore. I think I want the visiting. I don't need to see the enqueuing. Wait. Go back here. Copy worksheet output. Okay, now we're seeing many more states. This is good. This is good. And I don't think we need to worry so much about pruning right now. Because this is 357. And our pruning is not even all that aggressive. If there's a lower straight for the same position, or the same straight, right, then we will filter that out. So that's good. That seems reasonable to filter. But now this is a very basic, this is a very basic approach. I think what's wrong here is our priority queue. It's not quite accurate anymore. It's not just a matter of distance to the end. I could just do, you know what? We're switching away from whatever ace. This is a bad heuristic here. And we're just gonna go by the heat. This is purely just like a Dijkstra. There's a little bit more to this though. Right, because you're potentially adding like a +4 tiles. So it might be lowest heat, yeah, but it's how many tiles away? Which is why we do something like s.pos dist to end. Mm, let's just run it, see what happens. 96. 96 is still too high. Don't necessarily like that change. This is at least a little bit better here. But now it does matter more what your direction is. Oh, I wish I could think of a good heuristic. I mean, you know what? If instead of like spending 3 hours doing this, I'd sat down and spent like half an hour thinking about what a good heuristic should be, I'd probably be in better shape, right? This might be one where, like, if I were to call it a night and like go to bed tossing and turning, mm, yeah, yeah. So move east, move south, whatever. We have our starting points. Our priority queue is still not not quite where we want it. There's some other ways we organize it. Why is there like still a 2-4-2-0 at this point? So we need more aggressive pruning. I want to take that out at some point, but we also need more lenient pruning. What if we had what if we had no pruning whatsoever, right? We made that filter not. Let's do that. There's no pruning whatsoever. Oh, whoops. This is not even the worksheet. Wait, have I been like editing the worksheet this whole time? Oh no, did I copy paste into my actual worksheet? Okay, let's take this out. Let's try this. We still get 96. Right now, there is no pruning. No pruning at all. Interesting. There's only a priority queue. And apparently what we're doing in the so that tells me right there. It's got nothing to do with our pruning, just our prioritizing what to pick. Is when we do get to a point where it's like potential 4-0, we do enqueue like the 4 moves, like 4 move down, right? And that adds all the extra heat from that. We also enqueue the forward movement, which is going to add less heat and be more desirable. So it's going to show up first, right? So that's good. And then we have, right, this all looks good so far. Um, maybe I should draw this. I should actually be thinking about this, drawing out possibilities. Oh, I see Black Deep. I missed your comment. For me, the constraint, what'd you say? For me, the constraint on how many consecutive moves you can make in a direction made it hard. Yeah, That is true. Like without that, this is just a Dijkstra. This is just an A star. Whatever. And it made it hard, not because it's hard to implement, but because it throws your heuristics all out of whack. And I don't know in what way exactly that does that. Not without like sitting down and think about it. Okay, this is a time for a pen. Mm. Um, Opening the whiteboard. Here we go. Let's just move somewhere new. Maybe we can zoom in a little bit. Is that even zooming in? I don't know what's going on. We can draw here. We're going to draw here. Black is too dark. All right. So we have a grid, right? And from here, we can jump to here or here. And then we can keep moving forward or like jump over, right? In fact, getting to 2, 2 is very hard. Is there a case where like looping back would be it? I feel like that's highly doubtful. Um, oh, you know what? That was another example, wasn't there? Why don't we try the other example, see how that reacts with our code. Okay. Day 17. Nope, nope, this is wrong. Day 17, 2023. Okay, we're gonna say this is example 2. There we go. Does it work on example 2? 72. 71. Wait. What's that off by 1? Oh, is it the case that I am getting the right answer? So I was getting 96. Like, maybe I'm getting the right path, but the wrong answer, right? So there's just like a math error in here somewhere. Okay, let's look for that. Let's look for that. Um, so my heat addition must be wrong. Let's start with an example. And we're gonna walk through this example here, moving right, right, down, right, down. And then we're gonna see how the heat increases and see if it matches up with our math, right? So we start on a 2-point. In fact, maybe I know where it is. But we're gonna start with the state that moves to the right. Oh, I just copy paste into my worksheet again. Yes, I did. Yes, I did. Let's just delete all that. Okay. And we're gonna start with our example state, not our example state, with our best state, which is the one that moves east, moved east, this state right here. Okay. And we're gonna play around with that. Start, point at origin. Like it might be happening at this first part. Yeah, okay, it's right here. Point at origin dot east. Because we don't get the point we actually start on. That's it right there. It's our starting points, not our addition of points. The line from start dot east, line from start dot south. Now we get 71. And now for the example problem, now we get 94. Okay, that was it. It should have been suspicious to me that 96 was really close to 94, and I didn't catch on to that. Um, let's add back in these filters. Actually, before we add that filter, let's look at how many states we generate. So how many print lines do we have that are still working? Okay. So we're going to copy that worksheet output, open up Scratch. 300 states, that's fine. I'm not going to do any more filtering. We're just going to go back to the main problem. Okay. It's running. And that works. It doesn't. Oh, nope. It is still running. No, I want it to stop. Wait, it says it evaluated. And it got the answer 94? No, I don't believe that. I don't believe that. We are going to add back our optimizations. Let's just make sure they don't fail on the example. We had like 300 lines, right? And I want to make sure that pruning actually does something. So let's filter that out. And it's still 300-ish lines. Right, and I was able to compute. Okay. Let's add that back in. We still get 94. Okay, that prunes stuff out. And that'll probably prune more stuff out the bigger the map is, right? So let's try that. 1137. Okay, 1137 is too high, which tells us that our pruning here is too aggressive. So let's do like -10. See if the answer changes. Right, that would change the answer. 1135. Okay, 1135 is a candidate. Let's go to 20. Oh, maybe that's too big. Well, let's see. Is that the answer for 1135? I have 18 seconds left to wait. Okay. Let's see. Let's make sure this 20 is running. Let's do. Oh, she's running. It took 2 seconds. No. Copy worksheet output. Oh my god, 573. Yeah, 1135 is probably it. Ah, I got it. Oh my god, I got it. And you know what? I think part two was easier. I think it is easier because you didn't have to I didn't have to change any of my filters here, right? These are all the same filters. The only thing that made it harder, and it's just like calculating the next states. And calculating the next states, like this is easy in theory. I just can't code right now. It's just too late at night. Ah, okay. But I got it. Thank you. Thank you. Ah, okay. Yeah, writing this code here should have been really easy. This code here did not need to change. Um, so I say that took too long for me. I would say part two is actually easier than part one here, and it took me too long for like bad reasons. But top 4,000 each. That's cool. Oh, Alpha, you're still here. Thanks for the clap. And who is this? Odan. Odan1, welcome. Thank you for the trophy. Where does that put me here? Um, this is the Scala Center leaderboard. It looks like people have given up. The person I'm worried about is Jan Peter. Right, they're the one who would be in the lead if they had this star. In fact, I just want to check what their potential is. So if they made this, um, potential is 90.165%. I don't know how many points that is. Oh well, I can figure that out. It looks like I flip-flopped with someone here. Yeah, I think my delta was definitely too long. Wow, it was an hour. It felt like 2 hours, but it took me nearly 3 hours. Okay, okay, y'all don't need to see me do that. I'm up to fourth on my own leaderboard. If you want to push me back to fifth, there's my leaderboard code. Um, I'm gonna commit this to GitHub after the stream. Here's a link to that. And for this problem in particular, I'll be very curious. Wait, you did what? You got 16.6? Oh, you placed 16th and 6th. Awesome. With what times? I mean, this felt like it should be an easy problem. And like looking at it now, it looks like the code not complicated. I don't know. I feel like there's too much rust on me, and I have a lot more potential. And you know what? That's a good thing. Wow, under 10 minutes for two. That's awesome. Well done. Well done. That's so good. Oh, and chat, thank you for the follow. So when streamers talk to chat, you're the one they're talking to. Oh, the calendar's changing. Look, we've got a flood of lava now. I had Dijkstra ready too. Like I wrote my Dijkstra up right away. In fact, it wasn't just a Dijkstra, it was an A star. Um, right, and if that just worked, then it would have been a 10-minute problem, but I had to optimize. It took me so long to optimize. And I got too tired to like figure out next states for part two properly. Oh, and not realizing my off by two was like just my starting states were wrong. Yeah. I think you have to get on the leaderboard on a day like this. Yeah, that makes sense. Yeah. I thought I had Dijkstra ready, but I wasn't ready. I did have Dijkstra ready. I'm just not ready. Well, okay. Thanks everyone for watching me make it to the end. We're gonna find someone to raid. Uh, if you want to share solutions, please do so in the Discord. I'll be very curious to compare solutions. I think mine can clean up nicely. That I want to see what else other people submitted. So let's do Twitch, admin the code. See if anyone is still on at this crazy hour. Finished AOC D17. Let's filter for admin code. Um, take a look at Zombie Shoe. Are they gone right now? It seems like they might be gone right now. Hudson, this is a new face for me. Are they doing today's problem? Okay, I think we know who we're rating. Oh, they're working on past problems, so they had a late start. So this will be familiar to everyone. We can see what they're doing. Why not? Zombie taking a nap, indeed. With Brett Hudson. All right. Well, thank you everyone for staying till the end. Sweet Radish, Zaran, Icy Black Deep, Alka, and all the new people who joined today. Have a good night. Good luck with everything else. Cheers. Oh, is it Ray or Raid? Do I have to wait longer? I don't know. Okay, I have to wait for the thing to go. There we go. All right.
I'm able to
Well,
handle
he's lucky.
31.